All right, we're back. We're on page 6 of note 16. We're talking about fundamental theorem, and we're talking in this particular page about like my favorite way to use it. So because a fundamental theorem is essentially an equation, right? It's the definite integral equals f of b minus f of a. You can rearrange it, and you can rearrange it in such a way that you can like think of yourself as moving forward in time, or think of yourself as moving back in time. It's like if you know where you are, you can figure out where you will be. If you know where you are, you can figure out where you were. That's basically what we're doing. So if you want to move forward, then f of b, the place you end up, is where you started plus your displacement. If you want to know where you started, you take where you ended up and you just subtract all of the displacement that you got. So you can move forward, you can move backwards. Basically, you end up doing this all the time. And I would say that these are almost always going to be calculator problems because, well, I don't know. These are called impossible. I call them impossible integrals because, like, why am I calling it that? This has no simple antiderivative. We haven't run into that much. Like almost every function you can, almost any function you can think of has a derivative. There's the rules, you apply the rules, you get a derivative. Antiderivatives don't work that way. The difference between like cosine of x and cosine of x squared, cosine of x has a simple antiderivative, it's sine. Cosine of x squared doesn't have a simple closed form antiderivative, like very challenging to find. Later in Calc 2, you'll learn a series approximation for cosine, and then you can use that to find cosine of x squared, and then you can integrate the series, but then that has an infinite number of terms. We're kind of like off the topic, but like integrals are just harder, I guess is the basic rule. So here, if I want to find f of 3, I know f of 1, and I know f prime. Well, just think about it. We know that the integral from 1 to 3 of f prime of x dx is f of 3 minus f of 1. So if I want to know f of 3 is just going to be f of 1 plus the integral from 1 to 3 of f prime of x dx. I'll use a calculator in a second, but like I'm just going to write them all down, I think. F of 6 given f of 10 and f prime. Okay, so you can always start, and definitely at the beginning, just start off by writing fundamental theorem, right? This needs to be true. That's not it. F of 10 minus f of 6. Now solve for what you need to know. So we're looking for f of 6, so add this to both sides, subtract this. So f of 6 is going to be f of 10 minus the integral from 6 to 10. So like, I don't think it could be easier. You just have to like be confident in what you're doing. And you're just going to write down, basically these problems are write down the fundamental theorem, acknowledge that one of the things is an unknown and everything else is known, and then you're basically done. So f prime is this, f of 0, f of 2. All right, so the integral from 0 to 2 of f prime of x dx is f of 2 minus f of 0. So we want f of 2. So f of 2 is where you started, which is f of 0 plus your displacement, 0 to 2, f prime of x dx. They're all just writing down the fundamental theorem, rearranging it. Not bad. This next one looks like it's trying to trick us. F is the function defined by this. Oh, so we know f of x? Oh, no. Okay, well, we do, but f of x is this. G of x is an antiderivative of f of x. So what does that mean? That means that g prime of x is f of x. That's basically what that's saying, right? If I integrate f of x, I should get g of x, which means that f of x is g prime. So we're good-ish. G of 3 is 5. Find the value of g of 1. All right, so 1 and 3 are involved. So if I do the integral from 1 to 3 of g prime of x dx, that should be g of 3 minus g of 1. The problem tells me that g prime is actually f of x. So I'm looking for g of 1. G of 1 is where we ended up minus our displacement. And then this is going to be g of 1 is g of 3 minus 1 to 3 of f of x dx, because f of x is g prime. So this one just has like an extra step to trying to confuse you, right? F of x, g prime. And that's because g is an antiderivative of f. Okay, so now I'm just going to use a calculator to get these numerical answers. I'll probably like write them in as I go. Then I'm gonna come back and do this problem. So let's see, this feels like a short page, which usually means I'm about to screw something up. That's I feel like that's usually what that means. So let's see. Switch. What are you doing? Switch. Go. Okay, calculator page. All right, so I want to do 1.256 plus the integral. So when I press enter, it's going to look exactly like you want it to. Cosine of 3x squared, comma x, 1 to 3. So this is 1. Wow, that's like small area. Make sure you're in radians when you do this. So I'm going to jot that down, and you should too, and then we'll be able to move on. 1.265, 3 decimal places, fine. All right, f of 10, so 8.654, and then we're subtracting the integral of natural log of x squared minus 4, comma x from what to what? 6 to 10. So negative 7.620. I hate that kind of rounding. Negative 7.620. I hate when it like cascades through a couple of things. I just like, it makes me uncomfortable. All right, f of 0 is 1, and we're adding the integral of sine of pi times e to the x over 2. Crazy. X from 0 to 2. 1.157. There's like no way to do these other than with a calculator, so we're not taking the easy way out, we're taking the only way out on these problems. And then for the last one, we need to do g of 3 is 5 minus the integral of square root of x cubed plus 2, comma x, and we're going from 1 to 3. Negative 1.585. Negative 1.585. There we go. Okay, so I think that's that. It's my favorite way, definitely, to use the fundamental theorem is to rewrite it. And well, I mean, my definite favorite way is to use a calculator. So everything is coming together. We get to rewrite it. We get to use a calculator. It's nice. All right, and then this looks like some geometry, and we're pretty good at our definite integral geometry. Just don't lose sight of that, because that's weird. All right, so g of negative 2 is going to be, we can write it down, negative 2 plus the integral negative 2 to negative 2 f of t dt. That's not even geometry, because if you go nowhere, you get no displacement, so that's just negative 2. So this is going to be negative 6 plus the integral from negative 2 to negative 6. That's a problem, f of t dt, right? Because the lower, so we have to switch it and change the sign. Negative 6 to negative 2, f of t dt. And then negative 6 to negative 2. Let's do some geometry. Circle, radius of 2, so that would be 4 pi, but half of it. So 2 pi, but negative 2 pi. So negative 6 minus negative 2 pi is negative 6 plus 2 pi. I hate cramming that negative sign in there. Like I did it, but poor form. Okay. G of 2. So we always got to watch out for that. Like, should you change the bounds? Negative 2 to 2, f of t dt. This is negative 2 to 2. This is 1, and then 3, 4.5. So 5.5. So 2 plus 5.5. Geometry. We got this. D, g of 4 is going to be 4 plus. So these get bigger, like more than you would expect, because that you're always adding x, which is a little weird, but like it's not really uncommon. You'll see as you like go on. So negative 2 to 4. All right, so like this region here and this region just cancel. That's great. And then 1 to negative 2. So it's going to be 4. So we can't do our usual trick where we just like keep taking the previous answer because that like x is always kind of incrementing. So it's 4 plus 5.5 minus 2 is 3.5. So 7.5. Interesting. Wasn't something? Oh yeah, it's interesting, but I don't know if there's like anything more going on there. It's just generally interesting. 5, 2 plus the integral from -2 to 5 f of t dt. 2, no, 5 plus. I just copied the previous one. 5 plus -2 to 5. -2 to 5. Okay, so what more do we pick up here? From 4 to 5, another -1. Nope, 1.5. 1.5. That doesn't fit nicely. That's annoying. -1.5. Okay, so 5.5 cancels, and then -3.5. 5.5 minus 3.5 is 2. 2. So this is 5 plus 2, which is 7. Okay. And then g of 6. We're just doing geometry here. I wonder how many people are going to really watch these videos, because like once you know what to do, I don't know. If you're watching them, good for you. Good for me too, because I'm doing a lot of work on these. This is -2 to 6. -2 to 6. Okay, I mean, this is going to pick up another positive 1.5, so like those cancel. -2 to 6. So 4.5 minus 2, nope, 5.5 minus 2 is 3.5, and then cancels. 3.5. 3.5. 6 plus 3.5, 9.5. I believe that's it. Okay, so it's kind of a review, but it was like a little different because we had this weird like X thing hanging out here, and you got to watch out for that. So yeah, I don't know. Good stuff. So my favorite way to use fundamental theorem, a good practice problem. I'll be back in the next video, and then we'll do some more. So I'll see you there.